Hello everyone, welcome back to IndianCoding.com. Today we are going to study about statistic correlation versus casuality. So let's see what is it. Correlation measures the numerical relationship between the two variables. A high correlation coefficient close to 1 does not mean that we can for sure conclude an actual relationship between the two variables. A classic example is during the summer, the scale of ice cream at the beach increases. Simultaneously, drowning accident also increase as well. Does this mean that the increasing of ice cream sale is the direct cause of the increased drowning accident? No, that doesn't mean like that. But there is no relation between these things. We should provide the relationship what what are similar, what they exist. So that is what correlation called. Okay. So in that case, for example, the beach example in Python, here we constructed a fictional data set for you to try. Okay, so this is the particular I have given the details. Okay, so here I have mentioned that drowning accident is the array I have provided. Fine, these are the arrays I have provided. The second thing I have provided is the ice cream sale. That array is also provided here. Drowning equal to drowning accident, that array, plus ice cream accident is given this much. So I have to compare this, okay, and then find what is the relationship between them this. Okay, so I will just write these detail. After that, the output will be provided. So in that case, in other words, so the answer is probably not after comparing all this sense. In other words, can we use ice cream cell to predict the drowning accident? No, probably not. It is like that these two variables are accidentally correlating. Doesn't mean they are related to each other. All the arrays are same here, that the selling and the accident arrays are same. You can see on screen, they are same. But that doesn't mean that they are correlated to each other, right? There is no sense like the sale is increasing, that is why the accident are getting are increasing too. No, there is no sense for that. So it is like that these two variables are accidentally correlating with each other. The output is created here for fine. That doesn't mean that these are the related to each other. What caused drowning then? Unskilled swimmer, wave, cramp, anything can be happen. So let us reverse the argument. Does a low correlation coefficient close to 0 means that the change in x does not affect? No. So back to question. So what is the meaning of this? It can be the same. Sometimes the two relation can be of same time, but that doesn't mean that it is going to work. They are related to each other. Fine. So that is what I'm trying to explain here. Casuality can be happen. So relation can be same, but that doesn't mean they are working, they are related to each other. Output will be provided, but there's no sense for that, right? So that is what I'm trying to say. Okay, so there is an important difference between the correlation and casuality. Okay, correlation, you understand, it will provide the correlation. Casuality means the two situations are getting same, doesn't mean they are related to each other. Correlation is the number of measure how closely the data are related, and casuality is the conclusion that X causes Y. Okay, so these are the two kinds of details that are provided here. I hope you understood what I am trying to say here. Okay, so I hope you understand what is the difference between the correlation and casuality. We can't compare two situations together every time. Okay, so that's all for today's class. Tomorrow we'll study about more features related to data science. Thank you so much.